In this video, we're simply going to discuss 2024 quiz 2, and the first question is on functions. It's a modulus function. They are saying let f of x be equal to the modulus of x minus 1. What is the domain and range of the function? And sketch the function f of x. So whenever given a function like this one, we always have to redefine the function into a piecewise function, and this is just going to become x minus 1, provided x minus 1 is greater than or equal to 0, or negative of x minus 1, provided x minus 1 is less than 0. So this is coming from the definition of anything that's in a modulus. So this is just for your own reminder's sake. If you have modulus of x, we just say you let it be x if it's already positive. If it's modulus of 4, we let it be 4, right? Then if it's modulus of something that's negative, we negate it for us to get it outside the modulus, because anything that comes out of the modulus expression has to be positive. Yeah, modulus makes everything positive. This is what we're basically saying here. And we have two pieces which we can then redefine to be x is greater than or equal to 1, or negative x plus 1, x is less than a 1. We make a table of values, and the table of values that we're going to make is simply going to be for each piece. So we'll start with the first piece. Yeah, the first piece is y is equal to x minus 1. We put x here, we put y, then we can just put negative 1, we can put a 0, we can put a 1. The same applies to the second piece, which is negative x plus 1. And this is now going to be x, y. We put negative 1, 0, and 1. You can put a negative 1 in this expression. It's simply going to give us a 2. You put a 0 there, you get a 1. You put a 1 there, you simply get a 0. And same applies to this part. We can put negative 1 there, you get a negative 2. You put a 0, you get negative 1. You put a 1 there, we get a 0. Now, we can easily, or we could have easily sketched this without even making these two table values. So when you just solve from the function, it was modulus of x minus 1. When you solve this, this gives you, when you solve x minus 1 is equal to 0, this gives you a 1. So meaning our turning point is simply at 1. And if you put 0 in the whole expression, you simply get a 1. So there's a piece which is like this. Okay, so there's a piece which passes here. So there's a piece which passes here, but then we don't show the other side. And there's also a piece which passes here, which goes like this. This is a negative 2 if I'm not mistaken. There's a piece as well which comes like that, passes there, and continues like that. From the two pieces, you're able to see that there was negative 1, negative 2, and then there's 0, negative 1. So this is supposed to be a negative 1 here, a negative 1. So we have something like this. This is what you're having. This is the first piece, which is x minus 1. This is the other piece with negative x, then plus 1. It goes like this. Yeah, now the domains are restricted. The first one is, it's supposed to be greater than or equal to 1 going this side. The other one is open at this same point going this side. So no wonder we are having these two pieces. Yeah, so this is what you're going to get as your sketch. From the sketch, you can also tell that the domain, so this can help us to answer the domain. Domain here is going to be all real numbers. They are allowed. Then the range, it only accommodates positive values. So the range will be from 0 going upward. That's the only time we're able to see the piece. So the other pieces that are down are not going to be considered. So you just have something that looks exactly like this. This is the graph of the function. And all numbers, all x values are allowed, but y values are starting from 0 going upwards. So this is the graph that was needed, and it answers all the questions on the first part. So we've given them the sketch, and we've also given them the domain and the range. So this is basically going to score you your 4 marks. So that's what we have on question number 1A. Then 1B, they're saying determine whether the function modulus of x over x is even, odd, or neither, and show that the function the square root of 1 minus x is 1 to 1. So we have to show, meaning it's already 1 to 1, we just have to verify it. So for the sake of understanding, before we proceed to question 2, you can try to attempt to sketch f of x to be equal to, let's say, 3 minus x. Let's see how you can come up with this. To just see if you understand how we did question 1, you can just attempt this. Okay, so question 1b, question 1b is just asking us to confirm whether the following function is even or odd or neither. So this is what you're having. You're having something like this. Now to verify whether something is even, odd, or neither, we can just replace in the function we put negative f of x. So if you put f of negative x, this is just going to give you that. Then you have a negative x down. This is giving us x, then this is negative x. This is ending up giving you 1. And then when you put f of x in the same function, it's still fixed. It's still going to be this. Modulus of x is just going to be x because x is positive, right? This is giving you 1. Now you notice that the numbers that you are getting are the same except the signs are opposite. So this is simply an odd function. Yeah, so there's a video on functions. If you're having challenges with this, you can just scroll on the channel. You'll see where we were checking, or the methods that we're using to check whether the function is odd or even. So you can pause the next video, the next part, then you can try to find out whether this function here show that this guy is 1 to 1 before you play the video. Okay, so if you want to verify that a function is 1 to 1, we always replace a in the expression in the function given. So if we put a, this is going to be 1 minus a. Then if we put b in the function, we're simply going to get a 1 minus b. Then we equate these. So we're going to say 1 minus a should be the same as 1 minus b. We can square both sides. This will just leave us with 1 minus a this side and also 1 minus b this side. This is because we squared both sides. We squared this part. Even this we squared. That's how we are having this. Then when we reach at this point, the ones can cancel because you can have 1 minus a is equal to minus b. When you take this 1 on the other side, you get negative a, negative b. This will just give you a over b. Hence, we have checked that the function is 1 to 1. Hence, f of x is a 1 to 1 function. Yeah, so verified. This is how you basically show. Another way to show that a function is 1 to 1 is by trying to sketch it. So this is going to be, if you solve 1 minus x is equal to 0, this is simply going to give you, this is going to be 1. So meaning the function is going like that, passing at 1. So it's 1 to 1 whenever you use the horizontal line test. The line only touches the function at one particular point. That's how we check whether a function is also 1 to 1. Then number 1C, they are saying solve the equation. This is the equation given here. Then number C2, they are saying find the values of x which satisfy the inequality. This is what you have. So you just look at the marks that are given. This requires less attention because this is just 2 marks, the first one. The second one needs a lot of attention because that's a 3 marks question. So we'll start with the first one. Okay, so we're having the square root of x plus 2, then plus x is equal to 4. The first thing we do is make this x go on the other side. This is going to be 4 minus x. Then here we can square both sides. So the main reason is that we always need to have one particular side with the square root. It has to be alone so that we're able to cancel it. Yeah, that's what we have. Then here, when you expand this will give you 8x, then plus x squared. This is going to give us x squared, then minus a 9x, then plus a 16 is equal to 0. Is it? This is going to give us a 2. So negative 2, this will reduce to a 14. So this comes to be negative 9, comes this side to be negative 2. So here we have this. Then we can solve this using the product sum factor method. The product is 14. The sum is negative 9. So we're looking for two numbers such that if we multiply them, we get a 14, and then add them, we get a negative 9. That's a negative 2 and negative 7. And this is going to be 7x, then plus a 14 is equal to 0. This will be x minus 2, minus a 7x minus 2 is equal to 0. X minus 2 is equal to 0, and x minus 7 is also equal to 0. This will give us two answers, which is 2 and 7, but we have to check them. We always have to verify them. So we go back in the question and we plug in to see if the right hand side will be equal to the left hand side. So if you put 2 wherever there's x, this is going to be a 4, then plus a 2. So I'm having 2 plus 2, then plus a 2 to see this is going to be 2. Then you see that this is 4, 4. So this is okay. So this is an answer. We try 7, 7, 8, 9. That's going to be a 9, then plus 2. Plus a 7, I mean, there's a 7, because wherever there's x, we're putting a 7, there's a 7 this side. So this is a 3 plus 7, then this is a 7. You are seeing there's 10, which is not equal to 7, right? So this is an extraneous solution. We just go with this. Yeah, so the only answer, x is equal to 2. That's the only true solution. That's basically what you get for 1C1. Then for C, Roman numeral 2, so C2, they want us to find the range of x values that satisfy this inequality here. So whenever you are given an inequality, you cannot cross multiply. You cannot do the cross multiplication. You have to take whatever is on the right, you bring it to the left. This is going to be 2x minus 1, x plus 2 minus a 1, greater than or equal to 0. And here you simply get to have your 2x minus 1 minus x plus 2. Down you just have x plus 2 greater than or equal to that. This will give you 2 minus 1 minus x minus 2, then x plus 2 greater than or equal to 0. And this will change to just give us x minus 3. Then you have x plus 2 greater than or equal to 0. So you have two answers. You solve the top part, it will give you 3. You solve the down part, it will give you a negative 2. Then now you're going to make a table to check. So we have negative 2, then we have a 3. When you put x minus 3 and then x plus 2, pick any number that's before negative 2. So I'll pick a negative 3 there. Any number in between here, I'll use a 0. Any number after this, I can use a 4. So if I put negative 3 here, the answer will be negative. This will be negative. This will be negative, positive. That will be positive. So I'm just writing the signs. Like here, 0 minus 3 is negative 3, but I'm just writing the negative part. Yeah, so this is positive. Then now I multiply this. This will be positive. This will be negative. This will be positive. So we want where this thing is greater than or equal to. So meaning this part and this part. So x should belong to negative infinity up to negative 2. Then union from 3 up to positive infinity. This is going to be the answer to your question 1C, Roman numeral 2. That's basically what you get. No wonder it was costing 3 marks. Then question 2, they have given us a quadratic and they're saying we need to write it in the form of x minus h squared, then plus k. This is just completing the square and you being able to sketch. So a total of 6 marks. So we're going to complete the square, identify the value of k and h, then tell them the turning point and also get the x-intercept. and the y-intercept, then we sketch. So it's a full question. So whenever we are completing the square, the easiest is for us to use this formula here. And our A is 1, our B is -5, and our C is simply 4. So making the substitutions, you can just have this expression here, and this is going to be x plus 5/2. Then this is going to be squared, then plus a 16 minus a 25/4. This will give us x plus 5/2 squared minus a 9/4. So this is the completed square form that was required, and from here we can tell them that h is equal to -5/2, or this is a plus here, sorry, this is a plus, this has to be a plus there. Yeah, this is a plus, so that is going to be negative, because they knew that this is going to be negative. Yeah, so this here is a negative. Yeah, so this is what you get. Your h is simply 5/that, and your k is simply -9/4. So this is the turning point. The turning point is simply 5/2, -9/4, which happens to be a minimum because, so we can just say because a is greater than 0, the value of a, so meaning the graph looks like that. And once you get this, you can solve the equation. You can solve this, your 5x plus 4. You can solve this guy. The product here is 4. The sum here is -5. The factors can either be -1 and -4. -4x minus that plus a 4 is equal to 0. You have x, then x minus 4, minus 1, then x minus 4. This is going to give us x minus 4 and x minus 1, meaning we have two answers, which is just x is equal to 1 and x is equal to 4. And the y-intercept, so these are the x-intercepts. These are called the x-intercepts, the answers you get. Then the y-intercept is just the constant in the question. When x is equal to 0, we're getting y is 4. The c is always going to be y-intercept. So now if we want to sketch this, we'll simply have the two solutions that we need to touch. This is what you get. Then we are having a 5/2. Then we are having a -9/4. So this is what we need to do. This is a 4. So the graph has to simply come like this. It turns at this point and it goes in this direction. This will be the sketch. This is the graph that was needed. Yeah, so that answers the question 2A. That's basically what you get. Yeah, so apart from this, we can now go to the next one. The next one is simply on finding the range. So they've given us the following question. Let me just show it. So the previous is just the answer to this. Everything has been shown. We will put it here. It answers the first part. We've told them the h and the k, and also the last thing here down, we're just telling them that the turning point, the x and the y-intercept helped us to sketch. We showed that. It will give you a total score of your 6 marks. Then question 2b, they're saying find the range of the values for k for which this expression has two real solutions. That's what you have. And also you can take note of the second equation. Yeah, so you have this. You can pause the video and attempt it first before we do it together. So if a particular quadratic equation has two real roots, it simply means that the discriminant is greater than 0. And from this case, our a is 1, our b is simply 6, and our c is k. So if we do the substitutions, we can have 6 squared minus 4ac to be greater than 0. This is just a 36. 4k greater than 0. This will be 4k to be greater than -36. When we divide both sides by -4, divide by -4, k is just going to be less than a 9, meaning it's all numbers from -infinity to 9 open. That's where k must come from. So this is the range of values where k should belong for this discriminant to be greater than 0. So that's basically what we have. That answers your question B1. And coming to look at question number B2, they are saying the roots of the equation. So there's an equation given. Yeah, this is question 2B2. The roots of an equation, the equation is given to be 2x then plus 4. These are simply alpha and beta. They want us to find an equation whose integral coefficients roots are simply alpha over beta and also beta over alpha. So we say to create a new quadratic, we always use this formula. Here we have to get the sum. So the sum is always going to be equal to your alpha over beta. In this case, we have these two roots, we are summing them up, which is alpha squared and beta squared over alpha times beta. And we should recall that the formula for alpha plus beta is negative b. So alpha plus beta is negative b over a. Then alpha times beta is just your c over a, which is just going to give us a 2. And you also do know that we have a formula for this thing here on top. We know to say alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta. This is going to be 7 over 2 squared minus 2. There's a 2 there. This is just a 49 over 4 minus a 4. This is a minus 4. So this is just going to give us a 49 minus 16 over 4. This is going to give us a 3. That's a 3 over 4. So alpha squared plus beta squared is simply the same thing as 33 over 4. Then divided by this guy here, which is alpha times beta, which is just a 2. This will simply give you 33 over 8. So this is the sum. We keep this. This is our S. Then the product is simply going to be 1 because these guys are reciprocals of each other. Because if we multiply this, you get alpha beta and alpha beta. This gives you a 1. So our answer is that the new guy that we're looking for is simply going to be like this, which can be further simplified to simply become this. This is the quadratic equation whose roots are alpha over beta and beta over alpha. That's how we do question number B2. So that's what you have. Then the last question is on polynomials. They've given us a polynomial and they want us to put it in form. So there's a polynomial 2c1. They're saying there's a polynomial here, a polynomial expression. And this is plus 3x squared minus 8x, then plus 3. They're saying we put it in the form f of x is equal to 2x minus 1. Then we are having what? Ax squared, then plus bx, then plus c. So that we tell them the constants a, b, and c. So we're just going to assume that this guy is a perfect, is a divisor of this. We can use long division, 2x minus 1. So this is going to be 2x3, then plus 3x squared minus 8x, then plus a plus 3. So 2x into 2x cubed is just going to be 2x squared. We multiply, that's going to give us a 4, a 1, I mean, this is a 1 there. Yeah, so this will give us a 1 here. So that if we multiply, we get back 2x3 minus x squared. Then here, we can find the difference. The difference will just give us 4x squared. Divide this, this is going to be 2x. We bring down this. This into, this is going to be, this times that, that's 4x squared, then minus your 2x. We try to find the difference here. So the difference, this is negative 8. This is going to be negative 6x. We bring down the 3. 2x into negative 6x, that's going to give us a negative 3. We multiply, that's going to be negative 6, then plus a 3. Yeah, so this will just end up giving you a 0. So this is a 0, meaning this is our quotient. This right here is our quotient, meaning your A is 1, your B is 2, and your C is 3, negative 3. So you found this, and your C is negative 3. Yeah, so once we get to this, we can further break down our quadratic, because we have a 2x minus 1, then we have x squared. This is simply 2x minus 3 here. Then we can break it down further. To break this guy down, the product is negative 3. This guy, the sum is just a 2. The factors, numbers such that when we add, we get this. This will be x squared minus 1, x, then plus 3x, then minus 3. This will be 2x minus 1, x and x minus 1, then plus 3, and x minus 1. And this is going to be 2x minus 1. You have x plus 3, and you have x minus 1. You have factorized it completely. That's what you get. So they didn't want us to sketch or to solve or anything. They just want you to factorize it completely. So this is where we leave it, because once you get this, you're going to have a quadratic and a linear expression. So the quadratic can further be broken down, and this is simply what we are getting. Yeah, so this is supposed to end. This is the answer that we're supposed to have as the final expression. Thank you so much for watching. Feel free to ask questions. If you have any queries, you can inbox the line that I gave earlier on.